Good morning. Today we're doing lesson 11.4, which is applying the Pythagorean Theorem and its converse. Converse means the opposite in math, not like the shoes. So we're going to apply the Pythagorean Theorem, which is a skill that we will learn, an equation we'll learn, and then we're going to do the opposite of it as well, or undo it. So in words, what the Pythagorean Theorem is if a triangle is a right triangle, meaning it has one angle that's a right angle, then the sum, or adding up the squares of the lengths, equals the squares of the lengths of the hypotenuse. So the hypotenuse is always the longest side opposite of the right angle. So this is the hypotenuse. And then these two other shorter sides are what we call legs. So the equation's telling us if a and b are legs, well then a squared and b squared, if we sum those up, add them up, they will be equal to c squared. So they're giving us here in this example a and b. We need to find c. So I know the equation says a squared plus b squared equals c squared. So I'm going to plug in b here and a there. So a is really 8, so I have 8 squared, plus b, which is 12 squared, equal to c squared. And now I'm going to simplify what I already know. I know 8 squared is really 8 times 8, which is 64, plus 12 squared, 12 times 12 is 144. That's equal to c squared. So we can just add these up. If you're not quite sure, use a calculator or add vertically here. 4 plus 4 is 8. 6 plus 4 is 10. So we have 208 equal to c squared. And then last, we don't want c squared. We want to know what is just c. So we need to undo this square. The opposite of a square, the power of 2, is to take the square root. Whatever you do to one side, you have to do to the other. So those will cancel and leave us with just c. And then we have c is the square root of 208. We're actually going to plug this in our calculator and round it to the nearest tenth, or 1 decimal. So in my calculator, I'm going to push second, and then this x squared button to get the square root right here, and then 208, and then end the parentheses, because 1 was already put in there, we got to end it, close it up, and it equals about 14.4. This is less than 5, so we leave it at 14.4. And there's our answer. Let's try another one. This time we now know b and c. We don't know a. But our equation is still a squared plus b squared equals c squared. So a we don't know, so we just leave it as a squared. B is really 5, so 5 squared equal to c squared, which is 10, so 10 squared. So I'm going to simplify what I know. This is just a. 5 squared, or 5 times 5, is 25. And 10 squared, or 10 times 10, is 100. It's not 10 times 2, it's 10 2 times, just like this was 5 times 5. So we're going to solve this. We want to get a all by itself. So I'm going to subtract 25 over to the other side. And we have a squared equal to 100 minus 25, well, if you have $1 and you subtract 25 cents, we're left with 75 cents or 75. And then last, to get rid of the square, we need to take the square root. Whatever you do to one side, you have to do to the other. So those cancel, and we have the square root of 75. Now, we could take 75 like we did in an earlier chapter and split it up into our perfect squares, like 25 times 3, and that would give us 5 square root of 3. So if they left it in square root form, you could simplify like we did in 11.2. But I'm just going to plug it in my calculator because it doesn't ask for it in the terms of a square root. So I'm going to plug in the square root of 75 equals about 8.66. We're going to round that up to 8.7. Alright, let's try a couple more. This one we just have b in terms of a square root, which is fine. We still know a squared plus b squared equals c squared. This is the Pythagorean Theorem. So let's plug in what we know. A is really 9, so we have 9 squared plus b squared. B is really the square root of 37 squared equal to c squared. Well, we know that a square root and a square cancel and leave us with just 37. And 9 squared, or 9 times 9, is 81. So we have 81 plus 37. That will leave us with 118. And then last, to undo the square, we need to do the square root. We'll do square root on both sides. And we have c equal to the square root of 118. Well, we don't know what that is. So I'm going to plug in my calculator. Second square root, 118. And we get about 10.86. Because this next number is higher than 5, we're going to round it up to 10.9. Again, if you wanted to, we could leave this as a square root of 118 and split it up into 2 square roots that we know and continue to go from here, but we don't need to. You can just use your calculator. Alright, this next one, we want to find out what is x right here, and we don't know what a, b, and c are. We do know, however, from the first slide here, that c is always the longest side, the hypotenuse. So c is always going to be the one that's all by itself. So the one opposite of the square root is c, so this side is c. These ones are a and b. It doesn't matter which one's which. So I'm going to say this is a and this is b. So there's a Pythagorean theorem. I know a is really just x. We don't know what it is, so we're just going to change it to the letter x. b is 2, so we have 2 squared. And c is 2 square root of 5 squared. So x squared is just x squared. 2 squared, 2 times is 4. 2 times 2 is 4. And then here we need to be careful. This, it's not just a square root, it's also multiplied by 2. So both parts have the exponent of 2, or we could write this 2 times 2 square root of 5 times 2 square root of 5. We have that 2 times. So since this is all multiplication, we can multiply the numbers out front. 2 times 2 is really 4, and square root of 5 times square root of 5 is really square root of 25, and the square root of 25 is really just 5. So we have 4 times 5, which is 20. Again, let me do that one more time for those of you that was confusing. We have 2 square root of 5, we have it 2 times. So since this is all multiplication, we can multiply in any order. We have 2 times 2 is 4. Square root of 5 times square root of 5 is square root of 25. And square root of 25 is really just 5. So 4 times 5 is 20. So that's where this 20 comes in. And we need to get x squared all by itself so we can get x by itself. So I'm going to subtract 4. We have x squared equal to 20 minus 4, which is 16. And then our last step, to undo a square, we need to take the square root. They undo each other, they're opposites. And leave this with x equals the square root of 16, which hopefully you know this one, which is 4. Alright, so now we're going to do the converse. Instead of having one side missing, we're going to be given all 3 sides, and we need to see, do they form a right triangle? The Pythagorean theorem only works for right triangles, with one having a right angle. So the converse of the Pythagorean theorem says, if a triangle has side lengths a, b, and c, and they say that a squared plus b squared equals c squared, then it must be a right triangle. The Pythagorean theorem said, if you have a right triangle, then a squared plus b squared equals c squared, so we're just doing backwards of that. If a squared plus b squared equals c squared, then it must be a right triangle. So the only things we know about a, b, and c is that c is the longest side, or the hypotenuse. So of these 3 side lengths, these are all side lengths, 72 is the largest, so I know that's c. These ones are a and b, doesn't matter which one's which. So if we plug this into a squared plus b squared equals c squared, we have 12 squared plus 71 squared equal to 72 squared. This is in the form a squared plus b squared equals c squared. So let's just see, does it work out? 12 squared, 12 times 12 is 144, plus we have 71 squared. Well, 71, this will give you the power of 2, gives me 5,041, and 72 squared is 5184. So all we need to do is add those two together. 5041 plus 144. Ooh, super close. Look at how close those are. 5,185. So, are these the same? Well, no, they're not the same. So this is not a right triangle, because a squared plus b squared does not equal c squared. Let's try a couple more. I know this side has to be c because it's the biggest of all three. It doesn't matter which ones are a and b of these two. So we have a squared plus b squared, so 15 squared plus 60 squared is equal to 61 squared. So let's plug these in our calculator. 15 squared, if you want to plug this whole thing in at once, plus 60 squared, this whole side is 3,825. Oops, 3,825. And then let's plug in 61 squared. 61 squared. For those of you that don't know, this also means to the power of 2, so either one you'll get the same answer. 3721, 3,721. Well, these numbers are very different, so we know they're not equal, so this one's also not a right triangle. Well, let's hope this last one is. I know 7.5 is the longest of all three of these, so that has to be C. These are A and B. So in our equation a squared, we have 4.5 squared plus b squared, which is 6 squared, equal to 7.5 squared. So let's plug these in our calculator. We have 4.5 squared. I'm just going to do the whole thing, plus 6 squared. On that whole side, we have 56.25. And then we need to plug in 75 squared, not 75, 7.5 squared. And we get, wow, same thing, 56.25. So yes, this one is a right triangle. All right, our next question asks about a ladder. It says, a ladder that is 25 feet long is placed against a house. So here's a picture of your ladder against your house. The bottom of the ladder is 10 feet from the base of the house. So from here, the bottom is 10 feet from the base of the house. How far up the house does the ladder reach? So they want to know how far up is the ladder from the ground. So they want to know that height right here, the blue length. Round your answer to the nearest tenth of a foot. So that would be 1 decimal place. Okay? 2 decimals would be 100th. So this is really a triangle. Here's our ladder. The ladder, ooh, that was really bad. The ladder, they told us, is 25 feet long. So I'm going to label this side here with 25 because we know that's the length of the ladder. We know the length from the base of the ladder to the base of the house is 10 feet. We want to know this part. I'm going to label it with X. So that's my triangle. We know that the ground and the house hopefully is standing at a right angle, going straight out of the ground. Hopefully your house isn't tilted. So the side opposite of that is going to be C. So C is 25, and these sides are A and B. So our equation, we can use the Pythagorean Theorem because we know this is a right triangle. A squared plus B squared equals C squared. So first we have A squared, which is 10, plus B squared, which we don't know, that's just X, equal to C squared, which is 25. So 25 squared. So let's solve this. 10 squared, or 10 times 10 is 100. X squared we don't know. And then 25 squared, 25 to the power of 2, or squared, is 625. So we need to get x by itself, so I'm going to subtract 100 here. So those eliminate, and we have x squared equal to now 525. And then last, to get rid of the power of 2, the square, we take the square root. Those cancel and leave us with just x. And then we have the square root, so second, x squared, of 525. And we get, it says round to the nearest tenth, so 1 decimal, so 22.9. 22 and 9/10 of a foot. So that's how long our house is, or our ladder is placed up against the house. And this makes sense that it's shorter than C, because C is always our longest side. The diagonal one is always the longest. Alright, so next it says find x. Not just, hey, it's right here. I need to find what the length is. Find the length of x. So if we're looking at this triangle, the one that has x, we don't know this side. We know this side is 14, but we don't know what this side is. So we can't find out the length if we don't know two of the sides. However, we do know this triangle here, we have two of the sides. We know this is 6, this is 12, and this we don't know. I'm going to put a question mark there. So let's use the Pythagorean theorem for this triangle first. A squared plus b squared equals c squared. Well, c is our longest side opposite of the right angle, so c has to be 12. A and b, it doesn't matter. I'm going to say this is a and this is b. So a we don't know, so I'm just going to put a squared. And b is 6, so 6 squared. This looks like a 6, I'm going to make that a b. And then simplify what we know. A squared we don't know. 6 squared, or 6 times 6 is 36. And 12 squared, 12 times 12 is 144. So we want a squared by itself, so I'm going to subtract 36 on both sides. So we have a squared equal to, well, this is hard to subtract, 4 minus 6, so I'm going to borrow. So 14 minus 6 is 8. 13 minus 3 is 10. So we have 108. And then last, get rid of the square by taking the square root. So now we're done with the a squared. We just have a equals, and we have the square root of 108. For the moment, I'm going to have you stop and don't evaluate this yet, because we need to use this exact measurement, not a rounded estimate. We need an exact answer to plug in for the side length here, because we don't know what x is. We don't want to guess or get it close. We want exactly what is x. So this is what our length of the side A is right here. So I'm going to, instead of that, I'm going to put in here, this is the square root of 108. So now I'm going to use what I know to find the length of x. I know this is also a right triangle, so I'm going to use the Pythagorean theorem again. Oops. Just going to move that, can't move it. So we're going to do a squared plus b squared equals c squared one more time. I know c squared is the longest side opposite of the square root, so c has to be 14. So 14 squared. A and b, doesn't matter which one's which. I'm going to say this is a and this is b. So a is really the letter x now. B is really a square root of 108. But b is also squared. So this is a squared, b squared, and c squared. Don't forget the squared there. It's not just 108. It's the power of 2. So we know the square root and the square cancel and leave us now with just 108. So that's why we left it as a square root, because I knew later we're going to have to do the Pythagorean theorem again for the next triangle. Well, Pythagorean theorem says to square it. Well, a square root and a square are opposites, so they canceled and left us with just 108. And then last, 14 squared. If you're not sure what it is, type it in. It's 196. So we need x squared by itself, so I'm going to subtract 108. That would be the opposite of adding. So 196 minus 108, 196 minus 108. Oops, that's not what that says. 196 minus 108 is 88. And then last, to get rid of the square, we take the square root. So we have, now that we are done, we can plug this in our calculator. If you wanted an exact answer, you could leave it as the square root of 88, but I'm going to plug that in my calculator. Second square root of 88 is about 9.38, or if we round up, 9.4. So decimal or square root depends on what they're looking for in your answer. Alright, let's try one more like this. So we know this is a right triangle, so we're going to use a squared plus b squared equals c squared. But this whole side is one of the legs, this is one of the legs, and this is the hypotenuse, or since it's across from the square root, c. So I'm going to say this is a and this is b. So I'm just going to plug in what we know here. A is 5x minus 1, but it's squared, plus b squared, which is x plus 2 squared, equal to c squared, which is 5x. So now a is really this whole thing squared. So we have really 5x minus 1 squared, or 2 times 5x minus 1. So we need to multiply that out. So I'm going to use a box to help me multiply. Don't worry, we're not doing any diamonds. We're just multiplying right now. So I have 5x minus 1 times 5x minus 1. So 5 times 5 is 25, and we have x times x is x squared. 5 times negative 1 is negative 5 with the x. Same thing down here, negative 5 with the x. And a negative times a negative makes a positive 1. So far, I'm going to just move this out of the way here. We have 25x squared. A negative 5 and a negative 5, they're all negative, so total we have negative 10. We're adding these up now. Negative 10x, and then plus 1. So I'm going to just rewrite this up here. 25x squared minus 10x plus 1. Then we have this next piece, x plus 2 squared. So we did this first piece, and we got what's in purple. Now we're going to do the blue piece. We have x plus 2 times x plus 2. Again, I'm going to draw a box to help me multiply. So I have x plus 2 times x plus 2. So x times x is x squared. X times 2 is 2x. Again, 2 times x is 2x. And 2 times 2 is 4. So in this group, we have x squared. A 2x and another 2x gives me a total of 4x. We're adding these up. And then plus 4. So I'm going to write this up here. We also have x squared plus 4x plus 4. And last, we have 5x squared. I forgot to put the squared on this one. So this last piece, we just have 5x times 5x. There's no adding or subtracting, so we can just multiply these. 5 times 5 is 25, and x times x is x squared. So I'm going to combine our like terms. From this equation, we have just on this side, we have a 1x squared, and we have a 25x squared, so that will give us 26x squared. Then we have a negative 10x and a positive 4x. There's more negatives, so 10 minus 4 is negative 6x. And then here we have 1 plus 4 is 5, and equal to 25x squared. So we actually need all the x squareds together, so I'm going to subtract this 25x squared over to the other side. I'm going to erase this part here. So we have 26x squared minus 25, that gives us 1x squared, or just x squared, minus 6x plus 5 equal to 0. So we need to figure out what is x. So we can actually use our diamond in our box here. I know this seems like a lot of work, but you guys know how to do all of these steps. So for our diamond, we're going to multiply our first term and our last term. We get 5x squared. Our middle term is negative 6x. The only things that multiply to get 5 are 5 and 1. But to add to get a negative 6, they both have to be negative, because a negative times a negative makes a positive, and adds to get negative 6. Then use your box. We have a negative 5x and a negative 1x in our diagonal here. First term was x squared. Last term was 5. So we just need to figure out or factor what multiplies to get x squared. Well, x times x. Here, x times negative 1 is negative 1x. And same thing here, negative 5x. Our last box works. A negative times a negative makes a positive. So these are our two answers. X minus 1 and here x minus 5, all equal to 0 because it was equal to 0. We wanted to know what were the side lengths here. So we actually need to set both equal to 0. X minus 1 equal to 0 and x minus 5 equal to 0. So if we solve this, I'm going to add 1. So x equals 1. Or here, x equals 5. Oops, x. So this is where we need to write out our side lengths. It asked us, find the unknown lengths. So if x is 1, on this first side here, on the first side, if x is 1, well, 5 times 1 is just 5. So I'm going to list, if I plug in a 1, when x is 1, these are my side lengths. 5 times 1 is 5. Also, when x is 1, here we'd have 1 plus 2, which is 3. And if x is 1, we have 5 times 1 is 5. 5 minus 1 is 4. So those would be our side lengths if we plugged in a 1. If we plugged in a 5, what would our side lengths be? Well, 5 times 5 is 25. 5 plus 2 is 7. And then 5 times 5 is 25 minus 1 is 24. So there are actually two correct answers here. You would need to list out both. Sometimes if you got like a negative side length, you could ignore that whole answer because you can't have negative sides. Alright, this one, not as much work. We're going to skip actually this last one. It was similar to the last one. It was a lot of work. So slide 8, it would be a good challenge problem if you'd like to do it on your own. But we're just going to do slide 7 and be done. It says a right triangle. Okay, so I'm going to draw a triangle. Has one leg that is 2 inches longer than the other. So these two sides are our legs. Remember, the long one is our hypotenuse. The length of the hypotenuse is square root of 130 inches. So put that on C. Find the lengths of the legs. So it says one leg is 2 inches longer than the other. Well, we don't know what the other is, so I'm just going to say it's x. And if this one's 2 inches longer, it would be plus 2, x plus 2 more. So let's find x. These are our two side lengths. I'm going to say this is A, this is B, and this is C. So we have A squared plus B squared equals C squared. So A is just x, so x squared. B is x plus 2 squared. And C is the square root of 130 squared. Don't forget the squares. So x squared is just x squared. X plus 2 squared is really x plus 2 times x plus 2. It's 2 times. So this one we do need a box to multiply, but this is the only, well, that's not a box. Only part we need to multiply there. I'll undo that quick. There we go. So we have x plus 2 times x plus 2. We get x times x is x squared. X times 2 is 2x. Same thing here. And 2 times 2 is 4. So I'm going to write my answer up top there. We have x squared. So not this one. This came from here. We have x squared. And we have 2x and 2x gives us 4x. And then plus 4. Equal to the square root of 130 squared. Square root and a square cancel and leave us with just 130. So we can combine our like terms. We have 1x squared and 1x squared gives us 2x squared plus 4x plus 4. And then we need to get this equal to 0, so I'm going to subtract 130. So those eliminate, and we have 2x squared plus 4x. And now 4 minus 130, there's way more negatives, different signs for subtracting. 130, take away 4 is 126. And now we need to do our diamond in our box because we have 3 terms. So for our diamond, multiply your first and your last term. We have 126 times 2. Well, actually, you guys, before we do that, if these have anything in common, we can factor it out. All of these are multiples of 2, so it's going to make our life a lot easier in a minute here if we factor out a 2. So if I take out a 2, I'm left with x squared. 2 times 2 is 4x, and 2 times something is 126. I'm just going to plug that in my calculator if I'm not sure. 126 divided by 2 would be 63. So 2 times 63 would be 126. Now, it's going to make our life a lot easier because when we multiply our first term and our last term, we just have negative 63x squared instead of a bigger number than that. 2x goes on the bottom. And what two numbers multiply to get 63? Well, 1 and 63, or 9 and 7. Those are the only two numbers I can think of that multiply to get 63. Well, 21 and 3, but that's not going to give us 2. We need 9 minus 7x will give us 2, and multiply to give us negative 63. So in our box now, we have 9x and negative 7x. Our first term was x squared. Our last term was negative 63. So we have x times x is x squared. X times negative 7 goes here. X times 9 goes here. So our two answers we have are x minus 7 and x plus 9 from here, all equal to 0. So when I solve these, remember we have to set both equal to 0. We have add 7, x equal to 7, and if I subtract 9 here, we get x equal to negative 9. So we need to look at our original and plug in 7 and negative 9. Well, think for a second. If I have a side length that is negative 9, is that going to work? You can't have a negative side length. So we know right away that this is an extraneous answer or an extra answer. We can ignore that. So we just need to plug in a 7. So find the lengths of the legs. If this side's just x, we have this side is really just 7. And here x is also 7, so 7 plus 2 is 9. So the lengths of the legs are 7 and 9. Like I said, we're going to skip this one. So go ahead and get started on your homework. If you have any questions, please let me know.